All right, welcome back to Math 30-1 videos. So today we're going to do transformations of logarithmic functions. So here we're just going to refresh our memories, put in things back into here. So remember that this is essentially just the function notation. Instead of an f here, they just put a log base c. Everything else is pretty much the same. They all apply the same way to any function, like the previous video said about exponentials. So we're just going to apply all of these transformations and make a new equation for this graph. We're going to call this new equation, let's call it g of x. Okay. Now, to start off with, I always like to write it out as function notation, then put in the function after the fact. So a vertical stretch by a factor of 3. So a vertical stretch, remember, that's your a value. It's reflected about the x-axis, so that also means our a value is negative. Do we have any horizontal stuff here? So we've done our vertical stretches and reflection. There's a translations, and that's it. Okay. So in here we have a translation 2 units to the right. So that's a -2 to the h value. The h value is actually +2. And 4 units up. So I'm just going to label out what our my h, which is +2, and my k value is 4. Okay. Now what we're going to do is we're going to put that into this equation right here. So my function is actually log base 3. So I'm just going to replace the function with log base 3. And wherever there's an x, I put x -2. There's in one spot, it was inside the log, and then a +4 on the outside. So there's our equation. All right. Now, it's nice to know what their graph looks like to start off with, right? Before we actually do anything like that. Just to see what the graph starts off with and how it's going to end up. So this is all essentially the same question here. Sorry, I scrolled a little too far. Come on. Oh, I know you want to go. There we go. Okay. So my original graph, so if you remember what our original graph looks like, it started off at 0, 1, 0, sorry. It's an exponential function, but it's the inverse of an exponential function. So it's going to look something like this. And because it's base 3, it most likely will probably look something like this to start off with. The next one, let's 3 to the 3. Oh, 3 squared, sorry, 3 squared is 9, so it's going to be, okay. So that's what my original log base 3 of x graph looks like. Now it's nice to know that, so when I know what my domain and range is going to be as well. So my domain of this graph, because I've moved this graph 2 units to the right, my domain is actually greater than 2. I haven't done any reflections this way, so it's still pointing the same direction. My range is going to be YER. It's very similar to an exponential graph, how the domain doesn't change. My x-intercept. Okay, so this is going to be a bit tricky to find out what my x-intercept is. Find out where does it cross the x-axis, we have to make y is equal to 0. Okay. Now, when y is equal to 0, so let's go through and try to figure that out. Same thing with the y-intercept. We'd have to make x equal to 0. So let me just put x equal to 0 here. So we make this equal to 0. So I put a little -3 here. I'm going to write a little bit small here because I'm running out of space in this little box. Okay, so I'm going to minus the 4 over, divide by -3. So minus the 4 over, and -4, divide by -3. That's what it looks like. So this ends up just being 4 over 3. It's because they're both negative, so they just turn positive. And I'm gonna find a place to write this. I'm just gonna say I'm gonna write this up here instead. Okay. So we have 4 over 3 is equal to log base 3 x minus 2. I want to solve for x here, so I'm going to change this into log form. So I have 3 as my base, to the power of 4 over 3. So these two guys, remember, they switch their spots. X minus 2, and then add the 2 over. So I can punch that in my calculator and get an approximation But what this is, so 6.33-ish. I'm just going to write that here. 6.33. It's approximately that. Okay, so we 6.330 approximately. What it should be. We're going to do the same thing. We're going to make x equal to 0. I can only hazard a guess that because we move this graph over to the right, it's not going to cross the y-axis. Only if we moved it to the left would it cross that axis. So let's just double check. Put a 0 in here. Oh yeah, the +4 as well. That's there. We'll do some math here. But what the log base 3 of a negative number, we can't do the log of negative numbers. That's one of our rules. So this is undefined. So there is none. This is an undefined answer. So there are no y-intercepts here. All right, my asymptotes here, because remember, exponential function is horizontal, vertical is going to be, log graphs have vertical asymptotes. If the original graph was at 0, the new graph is also going to be 0, but this graph is moved over 2 units to the right. So x equals 2. All right, so if I were to graph what this looks like, I can now kind of sketch this. So there's my x is equal to 2 line. We have an x-intercept of 6.330, somewhere right about here. I really don't have too much more about this graph, apart from the fact that it moved up 4 units. Yeah, that's pretty much all I have on this graph here. I could just look at my table of this graph here and just plug it into my calculator. So I can just do that. Hit the table, give myself some good points here. There's 11, -2. 11, -2, somewhere right about here. Yeah, because there's been a vertical, we got 5, 1. Right about there. We got 3, 4, right there. 5, 1. Oh, 5, 1. Oops, that point's right there, not here. So that. Okay. And what else we have? A bunch of errors after that. Oh, this should be a 3. Okay. I put this point in the wrong spot here. What did I say? 3, 4, right about here. Oh no. There we go. There's my graph. Looking good. We called that g of x before, so let's call that g of x now. Our mapping notation. Let's get my marker in red here. We just apply everything that we did at the top here to all my x and y values. So the only thing I did to my x values was I moved them over 2 units. And I applied a -3 to my y's, and I added 4. And there we go. Oh, these graphs didn't be in the right spot. I'm just going to have to add in the right spot there. Okay. So what we're going to do now is we're going to try to figure out how do we get from the original graph. So this graph here, this green graph, is called f of x. This is the original log graph. So I'm just going to mention that. And this darker graph here is g of x. Oops, g of x. I don't know why there's an extra bracket there. Let's put an extra one around there. I want to know how to get from the f of x to g of x. How do I do that? Okay. So we want to know some key points of how they change, if they have transformed at all. So you notice that here, this graph starts off and ends off in the same spot. So this point almost seems like an invariant point. You notice that my asymptotes are the same for both these graphs, because my asymptote for both these graphs is x equal to 0. I haven't moved side to side, so I can say my h value is also 0. And it looks like the same thing for this graph. I have an asymptote of 0, so I can also say that's my h value. Okay. Now, I don't know if there's been a k value, if it's just shifted this graph up and down, because maybe I could have shifted it up and squished it in, or I could have just stretched it, because it does have a different shape to it. It's definitely being reflected. That's okay, we have to figure that one out. We'll need some key points on the graph here, my new graph. I'm really not too worried about the old graph here. So we have 2, -3. Looks like we have a couple other points down here. Like here we have 4, -6. We do have another point down here. I think we only need 2 to do this. Yeah. Now I'm going to look at this other graph here. I notice I have a few other points here as well that I might want to use. So I got 1, 2, 2, 3, 4, 4. All right. We got another point over here we can use. I got a lot of good points here. Okay. So once we identified a few things, like what our h value is, I'm just going to rewrite our h values down here. Yep, come on. Yeah. My x, this is my asymptote. This is my h value. Let's just look at this really quickly and just see what it says here. It's been transformed, so I can say there's been a or a b or both, and there's been an h or a k value to go with this. All right. So let's double check here. So let's just say, for the sake of this question, that there's only been, so we could say there's only been an a value, not a b value. So remember, like in previous questions, like if there was an a value, could be changed into a b value. If there's a b value, it could be changed into an a value. So we could do the same thing here, where you could either find just a or the b, but you don't have to find both, just one or the other. If you want to, you could find both and compare the two graphs, and they should be similar to each other. Okay, so let's just say we're looking for an a value, just to do this one. All right. So I want to know what my a value is to create this reflection, and it kind of looks like a stretch to make sure it passes through those 3 points there. We know what the log base is. I think the log base up here, if I remember correctly, was 2. Yeah, log base 2. Oh, there we go. Log base 2. We know our h value is 0, so there's just an x here, and I can go plus k. All right. Now what we're going to do is just going to put some points in there and just double check. Or not even double check, just create a system or a solve for h and k using what we have here. So let's see. If I put into the equation, start with my writing on this part. Let's just say this first point. This first point is 1, 0. I don't know if I have an eraser on this pen. No, I don't. Okay. I just get cross it off. 1, 0. Okay. So if I put a 1 into here, I need to get a 0 out. Okay. So remember one of our rules for logs. If I put a 1 in a log, I get a 0 out. So log base 2 of 1 is 0. 0 times a is 0. So to make sure that this stays 0, k has to be 0 as well. So k is equal to 0. Okay, that makes sense. So what we know so far is we have a log 2x plus 0 for our k value, but we don't need to worry about that. So now the other point, so you pick any one of these other 2 points. So let's say I pick 2, 3. So log base 2 of 2. So if I put a 2 into this, I need to get a -3 out. Now remember our rules. The log base of a number that's the same base, same as the base that we have. So 2 of 2 or c of c or a of a, that's 1. Okay, you can plug in your calculator too if you want to. So a is equal to -3. Makes sense. Okay, so we've done a reflection. We've done a reflection, and it's worked out nicely. It's stretched. Let's see. So we're going to put that back into our equation. So a value is equal to -3 log base 2 of x. There's my graph. Right. You can verify to see if it works with this other point that we have here. Should work out. Log base 2 of 4, with 2 to the power of what is equal to 4, so that's 2. So 2 times -3 is -6. So that works for that point. It works for this point. It seems like it works for all those points.